This is Victoria Gamildar, and this is CE 6370.001, Design Analysis of Reconfigurable Systems, with prototyping on the Terasic DE1-SoC board. And this is the 10 most significant bits LED counter, and so I am assigning the 10 most significant bits to the output. So the output is count, pre-count is a internal signal, 31 down to 22. So it's 32 bits in total, the internal signal pre-count. Then I also have reset and direction here. I have assigned the pins, and in the GUI it shows count here. So clock, count 9 down to count 0, assigned to pins, and direction and reset. Also, as an alternative, I can also assign in the QSF file the clock and count pins. So next up, I will compile the design, and I'll be back when that finishes. And yes, I did compile the entire design on purpose. Just wanted to look at the research usage summary. And there's 33 ALUTs with the full design compiled, with 17 ALMs used. And then next, I'm going to compile the fitter. So I'll be back when that finishes. Alright, compiling the fitter was successful. And so within the fitter, research usage summary. Alright, so we have 17 ALMs used, which is same as before, and then 34 ALUTs used. The number of ALUTs changed to be greater by 1, but the ALMs did not change, and they were 17 when doing a full compilation and when doing the fitter. Wanted to check them both and seeing if there was any difference. And next, going through the timing analysis, and that quickly finishes. So next up, I will, use the timing analyzer and go into datasheet, report datasheet. And I have setup times, hold times, clock to output times, all of the counts to clock, and then minimum clock to output times. So you can see the rise and fall times here in the report data sheet. Then next I want the critical path, so report path, report entire path, longest path, critical path. The delay is 6.645 nanoseconds, as shown here. Longest delay. Alright, so good to know. Next up, so you've seen the assignments. So here is the constraint file specified here. And then next, program device. And this device was added. This was originally here, but this device was added. You can see the device name, constraint file is here. And then I will be showing the LEDs. The LEDs changing are faster than when we had the 4-bit, because the 4-bit had to go through, let me go back to the code. So the pre-count is 32 bits. It has to cycle through the less significant bits in order to change the most significant bits. So when there's only 4 bits displayed shown previously, the changing the LEDs was very slow. However, now, because we are displaying the 10 most significant bits, it will be much faster than previously. Okay, and then other things is during the 4-bit for most significant bit LED counter, when I compiled the entire design compared to just compiling the fitter, the number of ALUTs changed. So just some things to take of note. The fitter is more accurate when you specifically compile the fitter. And I will be showing the board. Here's the LED counter for the 10 most significant bits. And it is currently counting down. And if we want it to count up, we just change the switch. And then it begins to count up. As you can see it counting up. Okay. And then here are the pin assignments, and then here's the source code.